Hey guys, we're going to do something a little different starting off with 13.3. We're going to make a foldable. This is what our end of the foldable is going to look like. So go ahead and get your piece of paper, get your scissors, and the first thing that we're going to do is you're going to take the piece of paper, fold it in half, like so. Then you're going to fold it again, halfway down, and then open it up, and then you're going to meet in the middle, both sides, okay? And take your scissors, and I need you to cut this line and this line. So you have 4 little doors, and that's what I need you to do. And go ahead, and you can push pause and stop and do it and then pick right back up. So feel free to do that. When you're done, I need you to close your 4 little doors, and you're going to put A in the top right square, S in the top left, T in the bottom right, left, and C in the bottom right, okay? If you notice, this kind of forms a coordinate axis. Here's my x-axis, here's my y-axis. You already know that this area over here is quadrant 1. Then you have quadrant 2 over here with the S, quadrant 3 with T, quadrant 4 is C. Now, the little motto that I guess you can memorize to keep this straight is all students take calculus. Okay, so there's your little sentence. All students take calculus. All means sine, cosine, tangent. Sine, the S means sine. That means that only the sine functions are going to be positive. In the third quadrant, the only function that's going to be positive is tangent. And then over here in the fourth quadrant is cosine. So I know that that means nothing to you now, but just to kind of give you a heads up of what these letters actually mean. All right, then you're going to open up your foldable, and I need you to go ahead and make your X and your Y, and we're going to get started with these. This is called the bow tie angles, okay? We know that in a unit circle, here's 0, and we're going to draw a right triangle that goes out. We know that X is positive, 0 to 1, and we learned that from here to here is, in our unit circle, is 1, okay? So then this is going to be Y, and then this is going to be a theta. Then I'm going to do the same thing for all 4 angles. Now over here, you have a negative X. Y is still going to be positive. My radius is going to be 1. Okay, now our radius is going to change in the first couple of minutes, in the next couple of minutes, and I'll explain why in just a second. Okay, and here's 1, here's theta. Here's my theta angles. I'm just going ahead and doing that. Now, X is negative over here because anything to the left of 0 on the x-axis is negative. Y is still positive up here. But down here, Y is going to be negative. And in this triangle, Y is going to be negative as well. Okay? So we're going to come back to this. We're going to refer to this. But look over here. In the first quadrant, both X and Y are positive. Here, X is negative, Y is positive. In this triangle, both of them are negative. And then in this triangle, X is positive and Y is negative. Okay, when in geometry, you learned that, let me get this over here for you. Okay, in geometry, you learned about 3 special type of triangles, 45, 45, 90, and then the 30, 60, 90. Right triangles, okay? If the sides are 1, because we know in the unit circle, from here to here is 1, from here to here is 1. If I was to do the Pythagorean theorem, 1 squared plus 1 squared is 2, and then to take the square root is square root of 2. So my radius is the square root of 2. Now what we're talking about is going to be this point on the unit circle. Okay, so I want you to imagine that the unit circle goes around, and we're talking about getting this point on the circle, which is X and Y as a coordinate point. Okay, so here's our first example. Sine of 45, 1, 1, 1. And what we're going to do is we're going to find the cosine of 45. The cosine of 45 is adjacent over hypotenuse. Well, let's do sine of, sorry, I'm jumping the gun. Sine of 45 is opposite, which is 1, over the square root of 2. So right here, I want you to put sine of 45 degrees equals 1 over the square root of 2. Opposite over hypotenuse. Well, what's wrong with our problem? Our problem is that we have a radical in the denominator. So to get rid of it, I got to multiply by the square root of 2 over the square root of 2. So sine of 45 equals the square root of 2 over 2. Okay, next you have the cosine of 45, adjacent over hypotenuse. So you have cosine of 45 is 1 over the square root of 2 as well. Well, cosine of 45 is going to be the exact same as sine, square root of 2 over 2. Okay, now tangent of 45 is sine over cosine, or y over x. Okay, so therefore I can go ahead, sine of 45 over cosine of 45, which we know sine of 45 is the square root of 2 over 2. Cosine of 45 is square root of 2 over 2, which gives me 1, because anything over itself reduces to 1. So there's the tangent of 45. Now, what does that mean? Well, sine of theta is equal to y. Here is y over here, this angle right here. And cosine of theta equals x. So therefore, I have a point, when I'm writing this, x and y goes first anytime that we write a coordinate point. So therefore, cosine of theta is first and sine of theta is first. So if I was to ask you what is the point of 45, you have the square root of 2 over 2, which is cosine, and the square root of 2 over 2, which is sine. They're both positive. And also this angle is located in the first quadrant, where both cosine and sine and tangent are all positive. That's where that goes into play back over here with the bow tie angles. Okay, now the next one, you have sine of 30. Sine of 30, okay, we've learned that back in geometry that the short side was 1, the hypotenuse is 2, and the long side is the square root of 3. Okay, you learned all of that in geometry. So to find the sine of 30, it's opposite over hypotenuse. So we know that the sine of 30 is equal to 1/2. There's our answer. Cosine of 30 is adjacent over hypotenuse. So it's equal to the square root of 3 over 2. Okay, and then the tangent of 30, we know, is going to be 1/2 divided by the square root of 3 over 2, which if I bring this up, then I get 2 over the square root of 3, which that reduces, giving me 1 over the square root of 3. Well, I can't have that, so it's really the square root of 3 over 3. There is tangent. Now, feel free at any time you go back through and you make sure that you can stop me and then go back and listen again, okay? And here it is again, just to make sure, a sine of 30 and 60, because remember 60 is that angle right there. And then we can make it bigger for the other side. But the side opposite 60 degrees is going to be the square root of 3. So if I was to draw another triangle, making 60 degrees my reference angle, which we'll talk about in the next couple of days, then square root of 3 would be here, 1 would be here, and 2 would still be there. Okay? All right, the other side of the foldable. Also, in your free time, I want you to go ahead and get this copy down, which I'm going to cover next week on the other video. But we're going to do some examples. We're going to find the cosine of 240. Notice that I went ahead and labeled 0, 90, 180, and 270. So the first thing I'm going to do is I'm going to put where 240 is located. We know that 240 is located right here. Okay? Then I'm going to draw a triangle back toward the x-axis. All your right triangles are going to be toward the x-axis. Here's your 4 options. Triangle is going to look like this one, or this one. You never draw it to the y-axis. It always goes to the x-axis. Now, you're going to have 3 choices on your reference angle. It's either going to be 45, 60, or 30. Those are your 3 options, okay? And so 180 minus 240 means that this angle right here is going to be 60 degrees, okay? And it is in the 3rd quadrant. That's important. I want you to be able to tell me 60 degrees is my reference angle located in the 3rd quadrant. So right now I know that the only thing that's positive in the 3rd quadrant is tangent. But I'm dealing with cosine. So with cosine, I know my answer is going to be negative. So before I even continue, I know that I'm going to get a negative answer. Now, since I'm looking at the reference angle of 60, then 240 and 60 both have the same cosine value. So the cosine of 60 degrees is 1/2. And therefore, the cosine of 240 is going to be negative 1/2. There's my answer. Okay? Now, where do I get all this? Well, there's a nice little chart down here at the bottom that we're going to fill out. This is what you need to know, especially the sine, cosine, and tangent ones. Sine of 30 is 1/2. Okay, we've learned that over here. Cosine of 30 is going to be the square root of 3 over 2. And tangent of 30 is going to be the square root of 3 over 3. Okay, we've already proven those. All right, then for cosecant, all we're going to do, remember, is get the reciprocal of these. So the cosecant of 30 is 2. And then the secant of 30 is going to be 2 square root of 3 over 3. If you don't believe me, then you get the reciprocal of this. You're going to have radical 3 on the denominator. And so therefore you need to get it out of the denominator. That's how I got 2 square root of 3 over 3. And then for 30, cotangent of 30, it is the square root of 3. Okay? Now, since 30 and 60 are opposite angles of each other, their sine and cosines are going to be opposite of each other. So since sine of 30 is 1/2, sine of 60 is going to be the square root of 2. Cosine of 60 is going to be 1/2. That's how I knew that the cosine of 60 was 1/2. Tangent of 60 is going to be the square root of 3. Then I do the same thing that I did over here, the reciprocals. Cosecant of 60 is 2 square root of 3 over 3. Secant is 2. And then cotangent is the square root of 3 over 3. Okay? Now, so there's 30s and there's a 60 angles. Now for the 45s. Sine of 45, we've already proved this, square root of 2 over 2. Cosine, we know is going to be the same thing. The tangent is 1. Okay? cosecant is going to be the reciprocal of these, so it's going to be the square root of 2. Secant is going to be the square root of 2, and cotangent is going to be the square root of, I'm sorry, not square root, just 1. All right, what do you need to know? You need to have memorized sine, cosine, and tangent of 30, 60, 45. That's part of what you need to have memorized. Then you need to remember that cosecant and secant and cotangent are the reciprocals of these sine, cosine, and tangents. So if you know these, then you can find the reciprocals of the other 6. You're going to eventually automatically know, because you're going to be doing them so much, especially when you get into pre-cal, that cosecant of 30 is 2. But until then, the ones that I need you to remember are these 9, okay, to have memorized. And then these you can work out by finding the reciprocal, okay? All right, we're almost done with our foldable. You have the sine of 4 pi over 3. When I give you the angle in radians, I need you to keep every bit of your work in radians. Okay, so you have sine 4 pi over 3. Notice I label my unit circle 0, pi over 2, pi, 3 pi over 2. So 4 pi over 3 is located, because look, how I know that it's located is 1 over 3 over 3. So therefore it's going to be in this quadrant over here. Okay, so there's 4 pi over 3. Now the next thing I need to do is I need to subtract 4 pi over 3 from pi, which is 3 pi over 3, which gives me 1 pi over 3. So theta, my reference angle is pi over 3, which we should already know is 60 degrees. And this is located in the 3rd quadrant. So I'm dealing with all of 60 degrees, okay? So I'm looking for sine. It's in the 3rd quadrant. My answer is going to be negative. So sine of pi over 3 is equal to the square root of 3 over 2. So therefore, the sine of 4 pi over 3 is equal to negative square root of 3 over 2. And there's my answer. Here's my work. There's my answer. Okay? Now, we're going to stop there, and then we'll do our next 2 examples when we go on to the next lesson. So I would definitely fill out your foldable so you can refer to it, because once you work problems, you're going to want to have this handy for you. We're going to add to this foldable, but I think over 18 minutes of me just talking about everything is enough. And if you need to, I would go ahead and make some more flashcards to go with your radians and degrees. See, really, you should have known that 4 pi over 3 was equal to, I'll let you figure that out, and by memorizing your flashcards for that. So push stop, go back over, look back through what I've just said, and if you have any questions, do not hesitate to ask me. Okay, talk to you later. Thanks, guys. Bye.